As we step into 2026, we like to believe we're living at the cutting edge of cosmic history, that we arrived early, that the universe is still young, still unfolding, still becoming what it will one day be. It's a comforting idea. It places us near the beginning, close to the start of the story, as witnesses to something still unfinished. But what if that feeling is wrong? What if, by the time Earth formed, the universe had already been building stars, assembling galaxies, shaping planets, and possibly forming habitable worlds for billions of years? That doesn't prove anything, but it introduces an idea that is difficult to sit with. Maybe we weren't early. Maybe we were late. For nearly 100 years, cosmology has relied on a simple expectation. After the Big Bang, the universe should take time. Time to cool, time for matter to settle, time for gravity to do its slow, patient work. Stars were expected to ignite late, galaxies to grow gradually, structure to emerge only after long eras of darkness. This wasn't philosophy, it was math. The same math taught in universities around the world, the same equations used to simulate the universe itself, the same models that told us when structure should appear and when it should not. And for decades, that math worked. Observations matched predictions, simulations agreed with reality, and the timeline held together. Until we looked deeper than ever before. In July of 2022, the James Webb Space Telescope released its first deep-field image. It was meant to be a confirmation, a sharper picture of a familiar story. Instead, it quietly destabilized everything. Behind faint foreground stars, Webb revealed galaxies so distant their light began its journey when the universe was only a few 100 million years old. That alone wasn't shocking. Astronomers expected to see something there. What they did not expect was what those galaxies looked like. They were bright, they were massive, and some showed signs of chemical maturity. They didn't resemble cosmic infants barely holding themselves together. They looked organized, structured, established, as if the universe had been busier for longer than we thought. By early 2023 and continuing through 2024, astronomers analyzing data from the Sears survey began to slow down. Not because the images were unclear, but because the implications were unsettling. Independent teams, using different methods, working at different institutions, kept finding the same pattern. Galaxies that appeared too large, too orderly, too evolved for how young the universe was supposed to be. Some estimates suggested that stars were forming 2, 3, even 5 times faster than existing models allowed. That's not a calibration issue. That's not a rounding error. That's a timeline failure. To explain galaxies this large, this early, one of 3 things must be true. Either gravity behaved differently in the early universe, or dark matter, the invisible substance thought to hold galaxies together, clumped faster and more aggressively than we believed. Or our entire cosmic clock, our understanding of time since the Big Bang, is wrong. None of these explanations are comfortable. Each requires revisiting something fundamental. When leading cosmologists say that something essential may be missing, they are not being poetic. They are signaling that the foundation itself is under review. Dark matter is supposed to be the invisible framework of the cosmos, the scaffolding that allows galaxies to form at all. Without it, the universe should fly apart.
But what if early dark matter behaved differently? What if it collapsed sooner, formed deeper gravitational wells, or interacted in ways we do not yet understand? That could explain why galaxies appear fully grown so early in cosmic history. And it would quietly suggest something far more unsettling: that we may not actually know what controls structure in the universe at all. Now we return to the thought we began with. If galaxies formed earlier than expected, then stars formed earlier. If stars formed earlier, then planetary systems likely formed earlier. And if planets formed earlier, then stable, habitable environments may have existed billions of years before Earth. That does not prove that life existed elsewhere. It does not prove intelligence. But it challenges something deeper: our sense of timing. Because if the universe was ready long before we arrived, then our place in cosmic history may not be near the beginning. We may not be early observers of a young universe. We may be inhabitants of a universe that had already been waiting. As we enter 2026, we're not just turning a calendar page. We're standing at a moment where some of our oldest assumptions are being questioned by the universe itself. The James Webb Space Telescope didn't give us answers. It gave us a warning. The universe didn't wait. It didn't grow slowly, and it may have been ready long before us. We explore what lies beyond what we think we understand, where the answers stop and the questions begin. Subscribe to Beyond the Void. For Beyond the Void, the mystery continues.